This is a recorded reading on building your knowledge, defining problems, and designing solutions. Engineering often begins with a problem to solve. The problem may involve an existing design, or it may require the engineer to create something entirely new. In both situations, engineers seek to understand the problem they will be working on. What needs must be met? What materials do I have? How much time do I have? Questions like these are the first steps in defining an engineering problem. So question 2 on your guided reading asks you engineering often begins with a problem to solve. Engineers ask a few questions in the first steps of defining an engineering problem. They ask, what needs must be met? What materials do I have? How much time do I have? Defining problems. When defining a problem, engineers consider both criteria and constraints. Criteria are standards or specifications that must be met by a successful design. What precisely defines the problem to be solved? Criteria may describe what function a design must perform and the qualities that make one design preferable over another. What you're going to do is you'll write criteria in the margin, and then you'll underline what criteria are, and they have standards or specifications that must be met. Then in the right-hand column, you'll write criteria may describe what function a design must perform and the qualities that make one design preferable over another. Once a problem is defined and criteria specified, it may still be difficult to solve the problem. An engineer must consider all relevant scientific principles or other pertinent details that might limit or restrict possible solutions. Such limitations and restrictions are the constraints of a design problem. Constraints commonly include time, materials, cost, and safety considerations. So in the last paragraph, it was telling you that criteria are basically things that you can do. Constraints are things that you can't do. And constraints are limitation and restrictions. Examples of constraints are time, materials, cost, and safety considerations. So in summary, these last two paragraphs were discussing the requirements of an engineering problem. And both requirements can be broken down in criteria or constraints. Designing solutions. Engineers use scientific investigations when designing solutions. As in science, engineering investigations begin with identifying a design problem and asking questions about how to solve the problem. The next step is to identify the criteria and constraints of the problem. Clearly defining both criteria and constraints guides the initial design process and sets up requirements that will be used to evaluate the design solution. Next, an engineer will create a preliminary version of a design that can be used to evaluate how well that design meets its criteria. This preliminary design is called a prototype. Proto is a Greek prefix meaning first. A prototype is a specific type of model that performs one or more of the basic functions required in the design solution. So what you want to first do is circle the word preliminary. Preliminary means first. So your first design is called a prototype. And that prototype is not going to be the final design, but it's going to be the very first design. And so a prototype is a specific type of model that performs one or more of the basic functions required in the design solution. Prototypes often undergo multiple cycles of testing and modification. Engineers collect data during the testing process and analyze the data to evaluate the design. The data may be quantitative, numerical, or qualitative, descriptive, but should all be recorded in a systematic way. So once again, a modification is a change to the prototype. And just like in a fair test, you make one change only, and then you test it. When you test it, you're going to be collecting data. Data can be quantitative, numerical, or qualitative, which is descriptive. So descriptive would be fast or slower, yes or no, presence of clouds, yes or no, but should be recorded in a systematic way. We do this using data tables in science. So in summary, the engineering design process starts with defining the problem. Then asks you to specify your criteria and constraints. Then asks you to build a prototype. It asks you to then test. Okay, this is a simplified version of the engineering design process flowchart. There is a more official one, and you could use that as well. Please ask your teacher if you have any questions. Thank you.